Hello everyone! Today is my 8th day of my 30-day blog challenge. And it's been a while since my last video. But anyway, I want to continue my video on neuroplasticity. And first and foremost, actually, I want to bring clarity to the neuroplasticity term, because thanks to one of my podcast listeners, I actually mixed up two different words. Neuroplasticity and neurogenesis. There are two different processes in our brain. Neuroplasticity is our ability of our brain to form new connections between cells, whereas neurogenesis is the birth of new neurons. Both are important for us, and as we're aging, we are actually losing the ability for neuroplasticity and neurogenesis. But now we know that we can trick our brain into neuroplasticity and neurogenesis. And as I mentioned in my last video, exercises are very important for our brain to create new neurons. Another thing which I wanted to make clear about neurogenesis is that it happens most of the time happens in two different parts of our brain, which are hippocampus, is our memory hub, and another part of our brain is the ventricles, the lining of our ventricles, which are cavities in our brain. But I think most researchers now are focused on hippocampus, on neurogenesis, which happens in hippocampus. And exercises are promoting our long-term memory, because exercises promote the birth of new neurons in our hippocampus. Another interesting thing about neurogenesis is that new cells replace the old ones and took over the connections of the old ones as well between the cells. And another thing is why neurogenesis is very important, that actually when new neurons are replacing the old ones, they can also form new connections as well, which is very important for us. We cannot resolve our problems with the same level we created them, right? That's the famous Albert Einstein's quote. And it perfectly makes sense when we want to reshape our experience, especially if it's something painful or we have a growth mindset. We want to change our life for better. We want to learn something new. It's about neurogenesis and neuroplasticity. But how exactly does our brain work? And again, what else can we do to trick our brain into neuroplasticity? And one of the ways is Neurofeedback. Let me explain what I mean. So, with the advent of new brain imaging technologies, we actually can have more insight of what's happening inside of our brain. Okay? And what are those new technologies? The first technology which is worth mentioning is magnetic resonance imaging, which is MRI, functional magnetic resonance imaging, which is actually measuring the way our brain functions, not just static image, but it measures the blood flow in our brain, which parts of the brain are active or passive, let's say. And PET technology, which stands for positron emission tomography. That's another way to see what's happening inside of our brain, which parts of the brain are active or underactive or normal. MRI, fMRI, and PET technologies are very precise and accurate. Those technologies can provide with high level of accuracy, and they are excellent diagnostical instruments for medical specialists. MRI, fMRI and PET technologies are quite expensive machines. They are huge in size, but for everyday use we can look into a bit different directions, such as old EEG or electroencephalography. And that is why. So there is the image of the surface of our brain. So the surface structures of our brain are the youngest parts of our brain from evolutionary point of view. Good news that the youngest part of our brain, such as, for instance, frontal lobes, have executive function over our entire brain. At the same time, because it is the youngest part of our brain, it takes a while to take control over the oldest parts of our brain, such as emotional brain, right? So EEG or neurofeedback based on EEG can help us to regulate our brain via our surface parts of our brain. Here is the surface structure of our brain, and we can measure the activity of our brain by placing electrodes on the specific places on our skull. Then this information could be measured and collected in the form of lines, and it's so-called electroencephalogram. And those lines are actually waves, and we know that different brain waves are very specific to our different states, such as, for instance, alpha are specific to our relaxation state. A neurofeedback device can easily translate the information about our brain state in the form of images and sound, so that we can easily react to. For instance, if we are in agitated and arousal mode, this information could be translated into a blurred image of something, and our goal is to make this picture clear. And if we are improving our brain state, the picture is getting clear. So that's how it works. And there is a short video which explains how neurofeedback works in reality.
With neurofeedback, the client can learn how to train and regulate his brain activity by getting real-time feedback from his EEG. Tux is controlling the movement of the rocket. It will only fly when he is focused and the brain produces the EEG frequencies which meet the criteria set by the therapist.
And there are different neurofeedback tools. Personally, I'm using that very simple tool. Neurofeedback can help with a wide range of disorders, such as attention deficiency disorder, anxiety. It can help to relax your brain. And nowadays, a lot of people actually use neurofeedback for meditation. And I'm using it for meditation. Why is neurofeedback so interesting? Because so far we've had most cases either medication option or talk therapy, and the growing body of evidence shows that neurofeedback does have a high level of success in treating different types of mental health issues. I encourage you to learn more about neurofeedback, and if you're considering different types of therapy, you might consider neurofeedback as well. Thank you for watching this video today, and see you next time.